Okay, students, so now we're here. We've done angle proofs with algebra equations, some stuff you're familiar with. Now we're going to take the two-column proofs, so stuff we practiced last time, and now we're going to do it for a geometric shape, and we're going to do it for one of the most simplest geometric shapes of all time, the segment. All right, here's a segment right here. I'm going to call this segment HI. I'm saying hi. Hi, how are you guys doing? I hope you're having a wonderful day today. And regardless if you're having a good day or not, it's only going to get better because now you get to watch my awesome video. So reflexive property. For any segment AB is congruent to AB. All right, so you're just basically saying a segment is congruent to itself. Duh, that's obvious. All right, that segment would be congruent to itself. In all truthfulness, we're not going to use it too much this unit. It's not that important in Unit 2, but it is important in Unit 4. We use it like a billion times, so that's why we're practicing it so much right now. So reflexive, something I like to say is repeat. Reflexive repeat. All right, AB is congruent to AB. You're literally repeating what you have. Symmetric, if AB is equal to BC, then BC is equal to AB. Swap order. All right, so it's good to differentiate between the two. They're both, in my opinion, easy to understand, but you might confuse them. Don't confuse them. Transitive. All right, notice how AB is equal to CD plus EF. GH is equal to CD plus EF. Since they're equal to the same thing, they must equal each other. That's the transitive property. In transitive property, the lines are kind of blurred with substitution here and there, all right? And we'll just discuss it throughout the unit. And then substitution. So, AB equals BC, so I can substitute the BC out for another AB. I can say, well, AB plus AB equals AC. That's substitution. I like to think about basketball where you just take one person out, substitute another player in, all right? And then something we'll talk about too, again, minor, it seems like a minor detail in geometry, yet it is still important, is the definition of congruence, all right? So if segment, this reads segment AB is congruent to segment CD. That's how it reads, and that's because shapes are the same. When shapes are the same, we say congruent. So if they're the same, well then they have equal measures. AB equals CD. And this reads measure. So like with angles, we write the little m. Or I should even say, let me say length. Length of AB, so if you take a tape measure, the length of AB equals length of CD. Alright? Length is a number, that's why we use equals. Alright? Number. The same. It might be 5 feet, it might be 2 miles, centimeters, whatever that may be. That's the definition of congruence. So we just can go from congruence to equal. If segment AB is congruent to segment CD, then AB equals CD. Or if AB equals CD, this will blow your mind, we could also say AB is congruent to CD. Minor details, but we do go back and forth. Alright? So we're going to review some more things. We're going to review midpoint and segment addition postulate. All right, if CD is the midpoint of AB, what do we know about AC and CB? So again, let's go ahead and draw a picture. All right, I'm really good at drawing. I drew a point, drew another point, AB. It's telling me C is the midpoint, so it's in the exact middle, tick, tick. All right. We're going to talk about this a lot, but it's incredibly important to draw on our pictures. These tick marks are really important, all right? the more often we label and draw on our pictures, the more success we're going to have, especially in the future. So what do we know about AC and CB? We could say, well, breaks it up into two congruent segments, or that they have equal measures. All right, and we did midpoint problems in the past. All right, so midpoint cuts it in half, and then we have the good old segment addition postulate. If C is between A and B, so now we have to differentiate between and midpoint. So that means I just got some random segment here. I'm gonna put A, B, and C is between. So I'm gonna, where should I put it? Oof, right there. That looks pretty. All right. Remember the segment addition postulate. I can say AC plus CB equals AB. AC CB equals the whole thing. All right, and that's some stuff we're going to be using in segment proofs. We're going to be using midpoints a lot and segment addition postulate. And just for fun, let's practice a transitive problem. So we're going to draw segment AB. Sir, yes, sir. Boop. AB. Now CD bisects. Remember, bisect is just a kind of a fancy word, or it's a different version, or however you want to think of midpoint. CD bisects AB, so CD, it bisects it at point E. So we have this picture right here. So bisect, kind of like midpoint, that means boop, boop. I'm immediately going to put those tick marks because it bisects it. All right, drawing and labeling our pictures. Now it's telling me that AE and CE are congruent. So because of the midpoint, I knew AE was congruent, or let's just say equals. We're going to kind of simplify it. AE equals BE. AE and CE. It told us AE and CE were congruent, so I'm just going to kind of simplify and write equals. All right. This was given to us. So the midpoint, or the bisect, I should say. Let me write bisect there. Since it was bisected, we know AE was equal to BE. Then it was given that AE was equal to CE. So by transitive, we can say, well, BE equals CE. They both equal AE, so they must equal each other. And we're getting to Halloween, so we'll make him a little spooky. Alright, so stay tuned for next video, and we're going to dive into our first two-column proof.